Hi guys, what's up? I am Sonu and you're watching Mathematics Expert channel. In this video, I am going to discuss what is the domain, codomain and range of a function. In previous video, I have discussed basic introductory part of a function, that is what is the condition for a function, that is every element of set A is uniquely association with set B. In this video, I am discuss what is the domain, range and codomain. Now I am going to start a example that I have discussed in the previous video. First example is that for a function f a to b defined is equal to y equal to 2x minus 1, that is this is the condition for this is the matlab that is relation of a function. Here x belongs to set A and y belongs to set B. Set A has 0, 1, 2, 3 elements and set B has minus 1, 1, 3, 5, 2, 0. Now set A is, if you put x is equal to 0, then you will get y is equal to minus 1. If you put x equal to 1, then you will get from here y is equal to 1. If you put x equal to 2, then y is equal to 3. And if you put x equal to 3, y equal to 5. That is, it is the association of the set of elements of A with association with set of elements of B. That is, suppose a function is nothing but it is a machine. This is a machine f in which we put input that and it will give output fx, that is equal to y. So this is the association of the elements. Now what is domain? Domain is equal to set of all elements of set A, that is set of all possible values of x. Set A is nothing but is the values of x, which is input of the machine. Then it will get output fx, that is y. So input is x and y, output is y, that is values of x is input and values of y is equal to output. So domain is nothing but input, or we can say pre-image, that is just before image, or we can say collection of set A or set of elements of A for this particular example. For this particular example, set A is 0, 1, 2, 3 and x represents element of set A and x is called independent variable. X is called independent variable. Now coming to the point, codomain of a function. What is codomain? Codomain of function AF, that is nothing but set of all elements of set B. That is, set B has elements minus 1, 1, 2, 3, 0, 5. Thus, we can say what is the codomain of a function? Codomain of a function is nothing but set of all elements of set B. That is, B is equal to minus 1, 2, 1, 3, 0, 5. So, understand? Okay. Now, the next point is the range of a function. Just see carefully. Set of all elements of set B, not total elements of set B. That is a special type of elements of set B which are associated with elements of set A. That is set of all possible values of y, that is output of the function. That is, just say this function machine, output of this function, that is fx. So the range is nothing but output of a function. Thus we can say that range is set of all possible values of y, or we can say inputs, or we can say output, or we can say minus 1, 1, 3, 5 for this particular problem. That is, fx represents each elements of range and y is called dependent variable. Why it is called dependent variable? Because it is depend on the values of x, but x is independent. But why x is independent? But because it is depending on your own choice. So understand? Now I am claiming that range is the subset of codomain. Why? Just see by example. Suppose set A is equal to 0, 1, 2, 3 and minus 1, 1, 2, 3, 2, 3, 0, 5. That is previous examples. Fx is equal to collection of all ordered pair xy such that y is equal to y has a relation with x, that is equal to, has a rule y equal to 2x minus 1 and x belongs to A and y belongs to B. And an ordered pair is, if you put x equal to 0, y has element minus 1. If you put x equal to 1, y has element 1. And if you put x equal to 2, y has elements 3. And if you put x equal to 3, y has element 5. Also, since what is A cross B? A cross B is nothing but collection of all ordered pair such that first elements of ordered pair belongs to a set A and second element of ordered pair belongs to set B. That is, F is nothing but subset of A cross B. If If that is f is a relation from set A to set B. Why? Because relation is, just recall what is the definition of relation. The definition of relation is subset of a ordered pair of A cross B. That is subset of Cartesian product of two sets A and B. It is function is a relation. Note, very important point. All functions are a relation, but a relation may or may not be function. Why? Just you see this difference. After that, you will have clear why every function is a relation, but every relation may or may not be function. If for each value of x, correspondingly y has only one value, then it will be a function, that is single valued function. And if for any values of x corresponding y has more than one value, then it will not be a function, but it will be a relation, that is multi-valued function. Just you have to check whether it is function or relation. If you put x has a unique x has one value of x and you are getting more than one value, then it will not be a function. If you are putting only one value of x and getting only one value of y, then it will be a definition of function. So you understood what is the difference between relation and function. For every value of x, where you are getting only one value of y, then it will be a function, and for every value of x, you are getting more than one value of y, then it will be a relation. Now consider this by this example, the word function is single valued function. Consider example, set A is equal to 1, 4 and set B is equal to -1, 2, -2, 16, -16. Now find what is the Cartesian product of two sets A cross B is equal to collection of all ordered pairs in which first element belongs to set A and second element belongs to set B. Now this is our collection of ordered pair 1, -1, 1, that is first we fix 1 and associate all elements of set B 1, 1, 1, 1, 1, 1, that is up to, and after that fix 4 and all elements of set B. Now consider examples. A is equal to, I am defining from A to B by definition y equal to x square, where x belongs to A and y belongs to B. Then this is set A and this is set B, and I am defining a function f from set A to set B. For x equal to 1, y has a value 1. If for x equal to 4, y has a value 16. That is, function has a collection of ordered pair 1, 1 and 4, 16. That is, f is a subset of A cross B, because this collection of ordered pair is lying in the Cartesian product of, let's just see here 1, 1 and 4, 16. That is here 1, 1 and 4, 16. This is lying in the A cross B. That is, f is the subset of A cross B. This is very important point. Keep in mind, f is a subset of A cross B. And for each value of x, corresponding y has only one value. That is, see here, for x values 1 is equal to y values is 1, and for x values 4, y values is 16. That is, f is a relation which is a function, because I am putting here only one value of x and getting only one value of y. So it is a function, that is, which is also relation. Now consider the next example. F such that A to B, y is equal to x, where x belongs to A, y belongs to B. If you put x equal to 1, then we will get x, y is equal to 1 minus 1. That is, 1 is associating with -1 and 1. If we put x equal to 4, then you will get y is equal to -2 and 2. Then 4 is associating with 2 elements of set B and 1 is associating with 2 elements of set A. This violates the condition for a function. This is not a function. Just recapitulate the previous video. What is the condition for a function? That is, we have a subset f equal to 1 minus 1, 1, 1, 4, 2, 4 minus 2. That is, f is a subset of A cross B. A cross B, and for any values of x, corresponding y has more than one value. Thus, we can say it is not a function. It is a relation. That is, multi-valued function. Why multi-valued? Because after putting only one value of x, we are getting more than one value. So it is a multi-valued function, not a single-valued function. See, the word single-valued function means only one in output. That is a function. Clear? Now coming to the point, graphical definition of a function. What is the graphical definition? For graphical definition of function, how to check whether it is function or not. First of all, step 1 is that draw the graph of function, give graph of a given relation. And second step is draw a line parallel to y-axis. After drawing, check carefully whether line of parallel to y-axis is cutting the graph at only one point or 2 points. If it is cutting at only one point, then it will be a graph of a function. If it is cutting more than one point, then it is not a graph of a function. That is, if lines parallel to y-axis cut the graph of curve only one point, then it will be a graph of a function. If it cuts more than one point, then it will not be a function. Now suppose the example y equal to x square. This is the very simple curve. Y equal to x square is open upward parabola and draw a line parallel to y-axis. This is cutting at only one point, that is point A. So it is a graph of a function. Now suppose y equal to x, y square equal to x. This is the open rightward parabola. Now draw a line parallel to y-axis, cutting at 2 points at point A and point B. So it is not a function. Now draw. Now third example is equation of circle. X square plus y square is equal to 4. That is, it is a radius circle of radius 2 and center at origin. This is very simple curve. Now draw a line parallel to y-axis. It is cutting at point A and point B, so it also will not a function. Now suppose next curve is hyperbola. You know what is the graph of hyperbola? Y square x square equal to by 4 and minus y square by 1 is equal to 1. This is the left part and this is the right part of the hyperbola. If you draw a line parallel to y-axis, it is cutting at 2 points. That is point A and this is point B, so it is also not a function. Our next graph is suppose y equal to ln x. Draw the curve of ln x. This is very simple curve. This is y-axis and this is x-axis. Drawing a curve and draw a line parallel to y-axis, it is cutting at only one point, so it also a function. Now suppose y equal to 2x minus 1. This is very simple curve. It is simply a straight line. For x equal to 0, this is minus 1, and for x equal to 1 by 2, this is 0. And draw a line parallel to y-axis, it is cutting at only one point, so it is also a function. This is total about the graphical definition of a function. So thanks for watching. I am stopping.